So what we're looking at right now is the APIC for ACI, the application-centric infrastructure, which, if you recall, is Cisco's SDN approach for the data center. So we'll see here that we have this beautiful dashboard right off the start, but I want to point to the red notification at the very top. And that red notification is giving us a warning that we only have one APIC in this overall fabric that we've set up. So there's only one controller that we have. We should have three. That's the recommended best practice. If not, then you shouldn't use it in production. But you can do whatever you want to do. If you want to use one controller, that's your choice. If you want to use two controllers, that's your choice. They recommend three set up in the cluster. All right, so what are we looking at here? We're looking at, first and foremost, the system. And under the dashboard, we have an overview of the system health, the node health, the tenant health, really just giving us a 35,000-foot view of the overall health and well-being of the fabric that we have set up. Under the controller section of system, we have the ability to define policies and configurations for the controller itself. And you'll see right here, in this particular case, we only have one APIC. It's showing up. It's connected to Leaf 1 specifically. And if anybody's familiar with that particular product, what is it? What is it? Yeah, it's a Cisco ACI series server right there. And that's what we're going to install the APIC on, a C series server. Faults are going to give us the ability to identify any faults related to access, infrastructure, management, security, tenants, and a whole lot more. We'll see here that there are various faults. Some of them are critical faults relating to the infrastructure. From an operational standpoint, a config standpoint, we have some major faults as well for the infrastructure. From an environmental and operational standpoint, we have some tenant issues, some minor tenant issues in regards to configs. We have codes, counts, causes, descriptions that go along with it. Essentially, these are like syslog messages that we have here. And the reason why we have so many faults is that we are using the Cisco DevNet sandbox. So if you want to play around with the APIC, you want to practice configuring the APIC either through the graphical user interface, or you want to use code in order to modify the way that the APIC is behaving and configuring the overall devices in the fabric, then you have the ability to do so with the Cisco DevNet sandbox. So go to your favorite search engine, type in Cisco DevNet sandbox, and look for the ACI sandbox, and you'll be able to play around with it, mess around with it, and get more comfortable with ACI and the APIC that goes along with it if you do not have access to the actual APIC or an ACI fabric in your own organization at this point in time. So take advantage of the Cisco DevNet sandbox and play around in it. So definitely a lot of people are playing in this sandbox, and as a result of that, we're going to see a lot of different types of errors as people practice, as people test things out, as people try to figure out exactly what's going on with Cisco ACI and get a better understanding of it. In the real world, you might want to take advantage of config zones. Config zones give you the ability to divide up your fabric into different zones. So that way there you can have multiple configurations going on at the same time. So that way there you can test some configurations. If you're satisfied with them, you can then deploy them into, like we like to call it, the production environment, as opposed to having it in the test environment. Now, where does the magic happen? It's really under tenants. The tenant is the logical container or the folder for the various policies that are going to apply to whatever we're trying to accomplish. Now, a tenant can be just a single entity, a single application, a single service that we're trying to apply policies to. It could be policies that are going to apply to the entire organization instead of a single application or service. It could be policies that apply to a complete department and all applications and services that go along with it. So a tenant can have any scope from a single application or service all the way up to just creating one for your entire organization, depending on what your goals are for your organization. Look across the top, you'll see that there's already some tenants listed across the top. Those are pretty much the most common tenants that are being accessed. But when you look down the left-hand side, I want you to see that there's 3 of them highlighted. 3 of them highlighted, 3 of them in bold. We have common, infrastructure, and management. And these are the pre-configured tenants, meaning that if you do not want to create any tenant yourself, whatever is configured inside of the common, infrastructure, and management tenants are going to apply anyways to everything that you're doing, everything that you're trying to accomplish anyways. And any other tenants that you do create, they inherit policies from common, infrastructure, and management, meaning that if you don't configure something specific for infrastructure under your own tenant, then the defaults of infrastructure are going to apply to your tenant that you created. So you don't have to create policies for every single little configuration item that you come across in your tenants, because the defaults here of common, infrastructure, and management will apply as well to all your other tenants. So common is really for defining policies that provide a common behavior for all tenants in the fabric. So it's going to be usable by all the different tenants you have. Management is going to be for inbound and outbound connectivity, or pardon me, in-band and out-of-band connectivity from a management standpoint. And then we also have infrastructure tenant, which is going to be all configurations related to the fabric infrastructure, including the context and bridge domain used for the fabric, VXLAN overlays, and so on and so forth. So if you have configuration policies that you want to implement in common infrastructure management, instead of having to redefine them every single time in all the custom tenants that you create, you can just configure them in common infrastructure management, and then they would apply to all the other ones. We have our fabric, and our fabric is all about the spine leaf architecture. So under inventory, we have the ability to display the spine and leaf switches as well as the controllers attached to the fabric. I'm going to go ahead and click on topology here and see if it's going to show us the topology itself. Remember, we're in the sandbox, so if it's overwhelmed with the number of individuals playing in the sandbox, it could take a little bit of time to see our overall topology. And then we have also fabric policies across the top and access policies. So while that's loading, the fabric policies are going to be utilized to define the spine leaf configurations, or the policies that apply to the spine and leaf. And then the access policies are going to be utilized to define how connections are made to and from the fabric. So here's our overall inventory. We can see we have our 1A pick connected to leaf 1, and then we have leaf 1 connected to the spine, and spine connected to leaf 2. Remember, the leaves will never connect to each other. Likewise, spines will never connect to each other as well. So when I define fabric policies, the fabric policies are going to apply to all interfaces and anything that has to do with the spine leaf connectivity within this particular fabric. Whereas when I define access policies are going to apply to the interfaces on the leaf that are the leafs that go to those other areas of the network, or the servers, or whatever other type of equipment that we have connected to those leaf switches. But as you expand out any one of these folders over on the left-hand side, we have the ability to configure policies that are going to affect the overall spine leaf architecture. Under VM networking, this is where we have the ability to identify and create policies for virtual machines, hypervisors, virtual switches that are all part of the data center. So you can see here that we have VMware listed, Microsoft listed, OpenStack listed. That's by default. So now we have the ability to define policies for the interaction between Hyper-V and ESXi, VMware, OpenStack solutions, and so on and so forth. So the configuration policies, the access policies on how the interfaces are going to behave, and so on and so forth. So it's nice how we have the ability within the APIC, within the fabric, to define how that interaction is going to occur between those virtual machines, the networking, how it's going to occur between those virtual machines right from here. So we have the ability to truly interact with VMware, vSphere as an example, and the virtual switches that might be set up on those virtual machines. Layer 4 to Layer 7 services used to identify and interact with services such as firewalls, load balancers, context switches, SSL termination devices, intrusion prevention systems. So any other type of Layer 4 or Layer 7 device that we want to implement within our ACI, we have the ability to set up the policies that are necessary right here in Layer 4, Layer 7 services. We have admin. So under admin, we can control the authentication, the authorization, the accounting. We can set up schedules for one-time or reoccurring policy execution. We can configure records for policy logs, events, faults, health records. We can update our firmware. We can set up external data collectors, and a whole lot more. So administration tasks are going to happen under the admins tab. Then we have operations. This is where we have the ability to perform troubleshooting, trace routes, pinging. We have the ability to keep track of the capacity, because really there's a upper limit to what an entire fabric would be able to support. So we can keep track of the number of endpoints, the number of bridge domains, the number of tenants, the number of layer 3 contexts, the number of endpoint groups. We have the ability to keep track of the number of layer 4, layer 7 devices, layer 4, layer 7 graphs, hypervisors, virtual machines, virtualization ratio. So we can keep track of that usage to see what is the capacity that we're currently at and how much further can we go before we completely reach the capacity of what ACI is able to do for us. And then we also have the ability to optimize ACI. So it'll analyze ACI and figure out where we have deficiencies so that way that we can optimize. We can track endpoints as well. And so anytime you want to improve or troubleshoot, operations is really where you're going to end up going. And then last but not least, we have apps. And apps is all about the different applications that we have uploaded to our ACI, our APIC, I should say. So the All Apps tab right here, if we click on the All Apps tab, it displays all the applications uploaded to the APIC and allows us as administrators to upload packaged applications as well to the APIC. And then the installed apps, where we were before right here, displays all the apps installed by the admin on the APIC, and also we have the ability here to select and launch applications as need be. So we can see in our App Center, we already have some videos that we can look at. We have the ability to take a look at a video on downloading an ACI app. There's a user guide, a developer guide. So if we're looking for additional help as well, there's already some information in here, installed apps that we can go ahead and access and take a look at. So that is a 50,000 foot view of the Cisco APIC for the application-centric infrastructure.